If you've been using Unity for a while, you may have wanted to write more generalized components like this, with multiple inputs or outputs to handle a variety of use cases, and to avoid creating new scripts every time you need to access a basic monobehavior function. While I generally support this approach, and this example is pretty tame, it can certainly clutter up your inspectors, and if you already tried to improve on this with editor scripting, you've probably run into a few roadblocks, and you may have questioned whether it was even worth it to learn how to do this. However, with just a couple property attributes and essential pieces of knowledge, this trick actually becomes quite easy to replicate in future scripts and will get you on your designer's good sides. To start off, I only have two scripts. The first is this collision event class, which simply routes the results of our onCollision methods to Unity events, which we can handle in the inspector. The second is this transform resetter class, which takes some basic transform values as an input, and by calling this method, simply applies those values to the local transform. For this demo, all we're going to do is call this reset transform method from the onCollision of our events class. Here's how it looks. So this works, but let's make some improvements. Say what we really want is to ignore the scale and rotation components on our transform resetter instead of setting them to predetermined values. The easiest way to accomplish this is through booleans, and doing it this way will help us to get started on the attributes we need. So let's get it set up using boolean logic, even though that won't stay until the end of the video. In our transform resetter, add 3 booleans, one for each transform component, and add checks in the reset transform method. Great. Functionally, this piece is finished, but there's a lot we can do on the editor side. Let's create an editor script, which we'll call HiddenIfAttribute, inheriting from property attribute. Add a constructor that accepts a string and apply it to a class level variable. This string will be our ticket to referencing other variables inside a serialized object class, such as a monobehavior or scriptable object. It's also a good idea to add this attributes usage bit to most of your custom property attributes, since serialized properties are Unity's way of reflecting on fields. Next, inside an editor block above our class, create a custom property drawer for the attribute. This is the basic setup for an attributes property drawer, and it can give you a starting point for creating other custom property drawers in the future. Right now, this drawer doesn't do anything. It just routes the serialized property through the editor class. So before we go any further, let's add this attribute to our 2 monobehavior scripts that we started with. You may be wondering why we're using hidden instead of visible. I realize it's a little confusing and it made more sense while I was writing the script, but we'll change it soon enough, so just bear with me for now. Also, the built-in nameOf function is super useful in cases like these, in case we ever decide to rename our variables. Following the same logic for our collision event class, add 3 booleans for which to reference with our attributes, and add checks in the onCollision methods. Returning to the inspector, we can see that our Unity events aren't drawn in the way that we expect. Fortunately, we can create a quick fix for this using another attribute. Create a class titled EventDrawerAttribute and inherit from property attribute. That's actually all we need to do for this class, so we can move on to the editor side. I'll actually copy the existing logic from our other property drawer, since it will still mostly be applicable here. Add a using statement for Unity Editor Internal, and create a field for a Unity event drawer. I personally like using properties like this. It's a pattern known as lazy initialization, and it can save you a lot of null checks. I could use the null coalescing operator here to shorten our code, since Unity recently adopted C#8 support, but sometimes it just breaks for reasons that I don't understand, so I prefer using a ternary operator instead. Now, simply replace the editor_GUI.property field calls with Unity EventDrawer.onGUI. Add this attribute inside our collision events class. Then we can check to see that our Unity events are still not being drawn, because we forgot to add the custom property drawer attribute to our editor class. but now once again, they're being drawn as we'd normally expect. Next, let's do the heavy lifting for our HiddenIf attribute. We can access other properties using this property.serializedObject.findProperty line. I'll get a reference to our attribute using that lazy initialization pattern again, then use it to get the other serialized property. Accessing primitive data types from serialized properties is really easy. For example, here we can just use property.boolValue, and since this is for a HiddenIf attribute, we'll just return here if it's true. Then in the getPropertyHeight method, do the same check. When you want to hide a property from the inspector like this, I like to use this negative standard vertical spacing line, because just returning a 0 here will actually add a duplicate of that spacing in the inspector, so this just helps to keep it a little cleaner. Testing this in the inspector, we can see that this works as expected for our transform resetter class, but not for the collision events. We can fix this by modifying the order property in one of our attributes. In the constructors for our attribute, we can set a default order like this, or we can manually set the order where we want to use it. If we use both, the order we set at instantiation is the value that will be used. Now that our events are once again being drawn normally, let's fix this hidden visible inversion thing. Create a new property attribute called VisibleIfAttribute just below the HiddenIf attribute, and inherit from HiddenIfAttribute. If you're in Visual Studio, you can place your text caret on the class name and hit a hotkey, which might be Alt plus Enter or Control plus period, and it will automatically generate the overridden constructor for you. In the property drawer, add this true tag so that it will be a custom property drawer for classes that inherit from the past type. Then, when we check our Boolean values, append this inequality statement to handle our inversion. And don't forget the getPropertyHeight method. Then, in both mono behaviors, replace the HiddenIf attributes with VisibleIf attributes. Now that we have expected behaviors for Boolean referencing, let's upgrade this to use enums. In the transform resetter, create an enum to label each relevant value, add a flags attribute from the system namespace, and give each label an integer value, each as a power of 2. The way this works is when we write an integer in its binary form, each digit represents a binary flag, and we can then use this to perform bitwise operations on our enums. Remember to create a field for this enum, then let's add enums to our collision events class as well. For the sake of this tutorial, I'll leave the enum here without flags, so we can be sure to solve for both cases, flags or not. Moving back to the HiddenIfAttribute class, add a constructor which accepts an object value. I would use enum here instead of object, but Visual Studio throws an error if we try to actually use it. So add an enum field to the class and try to parse the object to that field. If it fails, I'll just throw an exception, but we could theoretically check for more types if we later wanted to expand on the functionality. Override this new constructor to the VisibleIf attribute as well. In the property drawer, our conditional checking becomes a bit more complicated, so let's create a method to handle this logic in one place. This method will accept a serialized property, which will be the conditional field, typed as either bool or enum, not to be confused with the primary serialized property passed into the onGUI and getPropertyHeight methods. We'll start by checking if our attribute had an enum passed to it, and if not, we'll assume it's just a boolean to check against, where we can just use the previous logic. When dealing with enum values from serialized properties, we have to know whether it's a regular enum or it has a flag, and we can do that check by using the type of the enum plus getCustomAttributes of the flags attribute type, and checking if it has any results. Now let's create a branch off of that and add some comparison logic. Since serialized properties store enums in the form of integers, we can't use enum.hasFlag, so we'll have to run this comparison using bitwise logic. We can get the corresponding integer value from the enum passed into our attribute by using this convert method. After performing a bitwise AND on these two integers, if the value equals the enum from our attribute, we know that it's a match and we can set the result to true. For a standard enum, we can call enum.getValues to get an array of all the enum types, then iterate through this array to find the index of the enum in this type, and clean out our previous logic from elsewhere in the class. Finally, let's remove our Boolean logic from our mono behaviors and replace it with the new enum logic. In testing, we can see that our standard enums aren't quite set up properly, but our flags do work. Let's quickly fix this by switching the start index to -1 and casting the array value to enum with a proper equals operator. Nice! Thanks for watching. I'm new to the tutorial scene, so any feedback you're willing to give will go a long way to improve the quality of future videos. Let me know in the comments if there's anything in particular that you liked or disliked. I'll do my best to answer questions, and I'd love to hear if there are any improvements you can make to the code, as well as any suggestions for the next one. Have a wonderful day.